after you install a WISER tracking system at your site, you'll be generating a stream of real-time location data. That's where tags are. I can search for this work order, and also what zone or geofence they're in. So I've defined here a geofence, a zone, and what time do they enter or exit that geofence. And you can of course use this just to find things in your facility. But what really makes that data powerful is to pass it to a shared database or over the API to another piece of software like an ERP or MES. So here, this instance is writing history data and event data to a database and then can be accessed by another program. Or I can open up, let's see, if I access the API through a call. So here, what is the status of this arena? Or I can get the fire hose of all the tag data as it comes in. And you can use that data to trigger automations to do things. So here I'm going to run through a very quick demo of how to use Microsoft Power Automate to do that. This is part of Microsoft's Power Apps that includes like Power BI. I don't mean for this to be a tutorial, but just a quick demo of what kind of things you can do using the API. To start with a very basic task, I just want to receive an email if the tracking server goes down, right? That's something I need to fix quickly. So I'll open up Power Automate here. I'm just using it through a browser. I've already set up a flow. That's what they would call a script. It has some trigger that starts it running, and then it has a series of actions that it does as a result of that trigger. So I'll open up that flow. And you can see I've set it to run just every 5 minutes. Every 5 minutes, it'll reach out and check an item. I'm going to skip these real quick and come back. It's going to make an API call like I just entered in the console, right? It's going to reach out to the arena status and get that response. It's going to parse that response. Here in Automate, you can upload an example. So query that command line, get the response, and upload that example as the schema to define what these values are. So it'll parse that response and return calibration, did the antennas move, etc. And I'm going to particularly reach out and grab this tracking value. And I just want to know, is it up or not? If it is tracking, I'll assign up to a variable. If it's not, then not. That variable is current state. So if I go back up here to the top, I've initialized a current state variable that I can then write in later steps. Now this API call, hopefully it returns because the server is running, tracking or not tracking if something's wrong. But the server could also be completely offline, in which case this API call will fail. And unfortunately in Power Automate, it treats that block as failing. So this would run, fail, and the script would stop. The flow would stop. So the way I've handled that is to put it inside a scope, and that whole scope can fail. If that happens, I have another scope that runs to catch it. So if I open up this scope, normally it would run on, is the previous step successful? But here I'm going to run if the previous step has failed. And then if it has failed, I'll set that same variable to just offline. And I'll come back to explaining this condition, but if it is offline or down, what I want it to do is email me and send me a Teams message. So the first thing you have to do is get a profile, get an Office profile. Here this is running as support@wisersystems.com. We grab that Office profile and then we can use it. So I'd also like to post in chat, in our Teams chat, as WISER support. and also send an email to support at WISER Systems that just says the tracking system is the current state. Now, if you just ran it just like that, every 5 minutes, it would send you a lot of emails. So the one additional step we have to do is to store the state. So to do that, back up here at the top, I'm first going to initialize a last state variable that we can then write previous data to. And I will store that data when we get there. So at the end of this flow, if the state has changed, we're going to update an item. That's a entry in a database somewhere. In this case, I'm using Microsoft Lists. So I bounce over to that list. We have a service monitor list and an item in here that's just creatively called Arena, and it has a status called that's currently set to offline. It's not running. I think it should be running, so I have to hit refresh. Okay, so it's now up. So over in our flow, we'll update that status item, the service monitor, with the current state. Status is current state. And we have to grab that by an item ID. That item ID comes from the very beginning. So going all the way back, the first thing we did when this flow ran was to grab the last state. I said, if the title is Arena, grab that data. And then I'll initialize the last state variable, which is a string, and I'll store it as the last state item out of that database, out of that list. Likewise, I also need to grab that item ID so I can rewrite to it. So I'll initialize the item ID variable, and again, I'll set it based upon that ID value. And so putting it all together, that's what that will do, right? It's hard to fit on screen here, but zooming in every 5 minutes, it's going to get the previous state. It's going to set up some variables to use while that flow is running. It will reach out to the Arena and get the status. If the status is running, it'll set that variable to up or not tracking. If that query fails, it'll set the state to offline. And then finally, there's a conditional block here that I skipped. That says, if the state has changed, then we'll send the emails. That way we only get one email when it goes down, when it comes back up. So also importantly, this conditional is comparing current state to last state, but it needs to run both if the previous step was successful or was skipped, because remember that previous step was the what to do if the API query failed. If it didn't fail, it'll be skipped. We still want the following steps to run to keep the flow running. So once we put that all together, we can test it. Trigger it manually just here for the test. I'll save it and run. All right, and that was very fast. You see it has a check mark by each saying that it ran. And if you're curious, you can click into these boxes and find out what it did. So here the query was returned. There's that JSON that was returned by the query. And here's how it's parsed. Calibration is good. There are 14 antennas. Not sure why tracking is not shown. So, zooming out again, this is a pretty simple way to make an automation without a whole lot of coding. We're going to add blocks, connect them together, and configure their steps. And the sky's really the limit here. So in our documentation, we have a list of all of the endpoints that are available. So for example, let's say I want to delete a tag's properties. I can come down here to tag properties. Here's the definition of what that API call looks like. Scroll down. That would delete all tag properties. We don't want that. This will delete the tag properties of just a current tag. Or let's say you want all of the tags that are in a zone. We have queries and filters you can apply. So you can say, I want all of the passive tags here. In this case, they're saying a battery value that's below a certain value. Just, is it a low battery? But you can also apply this to zones. And so you could say, give me all the tag IDs that are in a certain zone, and then pull that previous API call to delete all of their tag properties. So I hope that gives you a feeling of how you can leverage WISER Server API to do almost anything you want with the data. And you can do that automation in almost any automation tool. I just wanted to show you Power Automate as a nice, quick way to get started if you already have Microsoft and the Power apps available to you.